Welcome to solverfy.
So now we'll work on problem 102 from chapter 17. In this problem, we're asked to calculate the solubility of magnesium hydroxide in 0.50 molar ammonium chloride. So for this problem, we need to recognize that the solubility of magnesium hydroxide will increase because we're in a solution of a weak acid. But to calculate quantitatively, we need to set up the series of reactions which are going to be in play here. So first we can talk about the dissolution of magnesium hydroxide into its ions, Mg2 plus and 2OH minus. Now we have NH4 plus, which is our solution of ammonium, which will convert to NH3 plus proton, just one. And then finally, we have our reaction of water, but we're going to flip it, and I'll discuss why in a second. We want to be able to cancel these hydroxide and proton from this equation. So first of all, let's go ahead and see what we need to do to be able to cancel these products. So first of all, we want to have our protons canceled. So what we need to do is add our appropriate, or we want to have the hydroxides cancel. So we have to add 2 across the board here so that the hydroxides can cancel. Then we want to make sure we have the 2's canceling, the protons canceling. So here. Then we can add our compounds. So we get magnesium hydroxide plus 2 ammonium will produce Mg2 plus 2 NH3 and 2 waters. So now the issue is, what do we do with the K values? So what we need to do is we use the first reaction as is. So we put KSP is equal to 1.8 times 10 to the minus 11. Then for the second one, we multiplied it by 2. So we actually want to square the value of Ka for NH4 plus, and we get a value of 3.09 times 10 to the negative 19. And the Kw is actually, this one we multiplied times 2, this one we flipped and multiplied it times 2. So we're going to divide by Kw, and we're going to square it to account for the flipping and the multiplication by 2, and we get a value of 1 times 10 to the 28th. So what we do is we multiply all of these together to get the K for this reaction. And the K will be 5.56 times 10 to the minus 2.